In last video, we focused on the hypothesis testing on single restrictions for single parameters. In this video, we are going to expand it and start with a single restriction on multiply parameters, and then expand it to multiply restriction on multiply parameters. So let's start with a case. Let's start with the null hypothesis that we would like to test, whether the beta 1 plus beta 2 is equal to 0 against the alternative beta 1 plus beta 2 is not equal to 0. Basically, we would like to see whether the effect will cancel each other out. So the linear hypothesis, we're going to use linear hypothesis functions. Again, you know better than me that the first argument is going to be the LM object that we create. In case you didn't remember, it's actually something that we create in the first or second videos by calling the LM functions. Yeah, here. So, and the second argument again, like, is the restrictions. Although we have multiply parameters, we only have one restrictions. So we could simply put the what we want to test in the double quotation directly. So we would like to test whether the beta 1 plus beta 2 is equal to 0. And we can see that the p-value is 0.03848, which is smaller than 5%. So we can reject the null hypothesis at 5% level. If you would like to verify it again, like, you can use the F statistic that we plotted here. Like, it is the second row, fifth column. So we extract the F statistic out, and then again, like, we could extract the p-value, which is the second row sixth column, and then we can use the PF functions and provide the F statistic as well as the degree of freedom, because we still only have one restriction, so the degree of freedom is still 1. The degree of freedom 2 is df2 is the degree of freedoms for the unrestricted model, which is 83. If you recall the if you recall here, the unrestricted model has 83 degree of freedoms. So if you print it together, it's going to be 3.8%, just like the p-value extracted from the output itself directly. So yeah, this is the testing for one restriction on two parameters. But what if we have multiply restrictions? Say we would like to test whether each parameter is equal to a specific value against alternative, whether either of them is not true. So in that case, we're going to the first argument we are going to provide is still the LM object, but the second argument we're going to concatenate these multiply restrictions using the function C. We're going to use this C function to concatenate it as like the first parameter, to concatenate these restrictions. So this is the first restrictions, and then after we provide the first restriction as a character, and then we're going to use comma to separate out, and then provide the second restriction and also the third restrictions. And you can see that the p-value is quite small, which is less than 0.05%. So it's way smaller than 5% significance level, and hence we can reject the null hypothesis. So again, we can extract the F statistic, and then we could see that, like, it will give us the same p-value.